So again, this is work I've done in collaboration with Anthony over there and my advisor Chris Harrison, both from CMU. So recent and continued developments in 3D printing have dramatically reduced the implicit costs and lowered the barrier of entry for a lot of people. So now we have novices, hobbyists, and people outside of professional communities finally gaining access to 3D printing technology. But conventional additive manufacturing techniques are designed to print models with precise and rigid material properties, which limits the scope of objects that can be modeled. Although professional-grade setups are capable of interweaving soft and hard materials in one print, these setups are extremely expensive, and not to mention the added upkeep of replenishing materials that are also very expensive. So luckily, we've got work from the UIST and Kai communities that's exploring different classes of printed objects, such as using felted yarn or layered fabrics. And although these techniques require building a completely new type of 3D printer altogether. So in the same vein, we set to further expand the class of objects that can be 3D printed. So specifically, we wanted to explore whether we could 3D print strands of hair, because we haven't really seen it implemented for printed objects. So meanwhile, we wanted to do this without having to build a new type of 3D printer and while keeping costs relatively low. So our approach was inspired by the peculiar phenomenon that happens when a person operates a hot glue gun. So when hot glue material is extruded, as you see here, the glue gun immediately moved away, a string of residue forms unintentionally. So this effect often annoys users, but in this work, we exploit this phenomenon to create 3D printed hair. So it turns out that the operating principles of a hot glue gun are very similar to fused deposition modeling, or FDM 3D printers, which happens to be the most affordable class of 3D printers in the market today. So by extruding a little bit of material and slowly moving the printer head away, we can emulate the annoying stringing effect. If you repeat this multiple times, then you get 3D printed strands of hair. So essentially, we are turning a bug in FDM printers into an actual feature for creating 3D printed hair. So here you can see a video of an actual 3D printer performing this action. And here's what the output looks like. So there's been recent work in the academic community and also in other wider maker communities related to this approach. So first, let's talk about industrial techniques. There exist industrial techniques for incorporating hair and bristles into everyday products. For example, special purpose machines insert synthetic hair into injection molded plastic models, like in your Barbies. Similarly, bundles of fibers can be mechanically sutured to create brooms and toothbrushes. This is how it's done. Wigs are fashioned using a clever combination of synthetic hair and actual real hair, but these need precise measurements from an actual wig master, and in addition, many hours required to manually knit those thousands of hair. In the maker community, there's fiber bridging, which extrudes bridges of materials across gapped endpoints. With sufficient density, the bridges form into bundles of fiber. However, this technique is mostly aimed at bridging points in a model and is not intended to create true strands. But it's definitely related. And finally, in the mechanical engineering community, they've looked at micro pillars, which, if designed in a specific way, it can be used to model fairly dense hair. You've probably seen this in Jifei's work at the demo sessions last Monday, which is incredibly cool. Although their approach uses a DLP printer, which is a totally different technique altogether. So we now describe our basic technique using an unmodified 3D printer. So just to give you some context, we use a desktop FDM printer from PrinterBot, which costs $300. Meanwhile, we use an open source software called Repetier Host, which I'm going to show later, to simulate the printing process, which was very helpful for us to iterate these parameters. And finally, our setup uses PLA filament. Of course, other materials can be used. The steps here serve as a baseline. So this is basically what you need. First, you tell the extruder to move to a designated point. Second, you extrude a little bit of material. And then finally, you pull away. That's it. So when you repeat this sufficiently enough times, you begin to see strands of hair. The rest of the technique is then mostly focused on adjusting the parameters related to these 3 lines of code. So, and also, I'll make this G-code available on my website, and you're welcome to download them. Again, here's what the output looks like. Here's what it looks like printed in different filaments. So if you're familiar with G-code, there are parameters that you can set very easily. So some of these parameters include temperature, how hot does the extruder need to be, how much plastic material to extrude, and where the printer head should go after that, and how fast it should go. There are also other parameters that can be tweaked, but these are the ones that we found to affect the output more dramatically. Also, here's the hair printed. If you saw the demos, there's a bunch of fibers and prints that we made. I'm also happy to show them to you here after the presentation. Okay, so the other key idea here is that when generating multiple strands of hair, it's important to terminate the previously extruded one. Otherwise, the strand may loop back and it gets entangled, and then you get a messed up print. So we found 3 examples of how to do this. First is you can pull away. So if you just go far enough, it will cut itself, which is cool. Or you can retract the filament. So the default mode of 3D printers is to extrude, so going down. You can actually tell the machine to go up. So you can move away while also going up is another technique for cutting it out. Or you can actually manually scrap the filament itself. So you can create like a surface that will allow the printer head to take out whatever it's in its bottom and then just go back. So it's like a cleaning surface, basically. So here I'd like to show you an example of what this process looks like. Where's my mouse? So here's just different layers of the print. So you extrude, and then you pull away, and then you go to the corner. This is just for making it so that it pulls away. And then you can see this other base here. This is like a scrapping surface, basically. So, but the process of building the scrapping surface, you're actually cleaning the head. So this is just one example. And again, this software is Repeater Host, which is open source, and it allows you to modify the G-code. It's really useful. Okay. And so again, if you abstract all these parameters, then you get a design space. So let's go through each of them super quickly. So of course, you've got length. You've got thickness, which can be adjusted by changing the speed and the extrusion amount. You've got density, which you can control the root positions and where the X and Y positions are going to be. You've got distribution. So there's one way, if you stack all the layers, there's one way where you just stack them at the same position every time, and they're going to be linear. Or you can interweave them assembling bricks on a wall so that they look more natural. So you stagger the different positions. And also there's the hair flow. So what we do is mostly it's just linear. You start in one position and then just go like that. But you could adjust where the printer head goes, actually. So you can have a curved surface and go orthogonal. That way you can get a mohawk as opposed to just a straight spike. So these are some parameters that you can adjust, and the details are in the paper. Also further, because the output is kind of just like hair, it's very hairy, several post-processing techniques are possible which mirror human hair practices, and it's applicable, which also expand the design space. So here you've got cutting, very straightforward. You can curl, so if you apply heat, you curl it and you apply a little bit of heat, you can actually make this curl. Same process here at heating, so you put a blow dryer and you curl these hairy hair. And then you can do braiding, because it's just like hair, basically. Also, you can ponytail, if you're inclined to. Okay, so let's look at example output. So here you've got a wizard. This is intended to be a Gandalf. So you've got medium density, long, and straight hairs. You've got a troll. The hairs are long, medium and thin. It's flowy, but also a little crazy at the top. You've got a brush where it's extra thick, short, and straight. You've got a finger, as you saw earlier, curly, short, and sparse. There's another key parameter here. You've got a horse that has medium-length hair, very thin and flowy. Or you can have horse that has dense, fine thickness, and short. Okay. Like all techniques, our approach has limitations, so let's quickly go through them. First, the maximum hair length of printed hair is bounded by the size of the printer bed. So our printer bed is 100 millimeters by 100 millimeters. So the length of hair is bounded by that dimension. You could go diagonal, but obviously bigger printer heads can increase the hair length. So a lot of people ask me, can you 3D print a wig? The answer is it costs a lot of time, and it's also you need like a gigantic printer bed. So the answer is no. Also printing time, because you have to print each strand, so that obviously takes time. Also, our initial approach to this one was go up, but then going up is a very slow process because you have the rod that is very slow. So we flipped it so that you can go fast. But if you have a Delta 3D printer, for example, that could go up very fast, then you could use that technique. Also, the extruder dimensions limit the density of your hair because it's hot. It will melt the neighboring hair. So a cool extension of the project is if you have a multi-degree of freedom extruder, and it's also very thin like a needle, you can actually print in different angles, and that would be pretty cool. Okay. And here we have a 3D printed Scott Hudson, which could become a collector's item someday. I showed this to Scott, and he approves of this print, except for the fact that it's missing some hair on the head. But nonetheless, we bring you a 3D printed Scott Hudson. And that's the end of my talk. Thank you.
Paul Ascenti at Adobe Research. Very nice work. What prevents the still hot hair from adhering to the already existing hairs that have been laid down on top of it? I would think that because it's still semi-molten, it would tend to stick to the hairs that are already there.
That is actually true, and we've observed that effect happening. And so what you do is you just have that limitation. So you just increase the gaps between the different hairs, basically, to avoid that. Also, you can choose you can alternate the layers. So instead of having hair at every layer, you can have hair at every third layer or every fifth layer. But again, the limitation here is just on the dimensions of the extruder. If you have something thin, then you can probably prevent that from happening.
One. Games with me. Games with me. Thank you. All right. Patrick Bowditch, Hasselplatten Institute. This is awesome stuff. I really like it. So I'm engineering along as I'm listening, and I'm thinking, when we did wireprint, there was a lot of the heating and cooling time, and so we try to keep it stretched. But in your case, you could actually move backwards with the print head when it's still warm, and you could get curved hair.
Okay. We tried our very best. We spent lots of time trying to do curly hair because that would be nice.
Curly would be very hard.
But we just can't. It's just impossible to model in the FDM. So it's an open space. We can't do it.
I mean, curly would be insanely hard, but if you just pulled and
back,
then quickly went back, and then it would sag in the middle, right? That you could do, right? And then you would go back and rip it off, and then you repeat. No?
Yes, it would curl, but then you can't control how it looks like, basically, because it's random at that point. When you do, we tried a bunch of times. We even tried doing zigzags, and you just can't. It will just go straight even if you zigzag.
No, what I mean is gravity, not left. Left, right doesn't work. Obviously, you pull.
Oh, that's actually a cool idea.
You pull,
okay.
and then you move.
I follow. Okay.
Okay, and we'll do the rest offline.
Yeah,
okay,
yeah.
cool.
That's awesome. Okay, cool.
Sorry, I was going to follow up on that because it seems like you actually could build support structure that you could kind of almost wind around, not wind around, but you could use that to
like rest.
Yeah, you could create the effect I think Patrick's trying to get at with support. It's like support structure for hair.
Exactly. Yeah. So the cool thing about it is that if you look at the software that we were using, I mean everybody is very familiar with this, but you basically have the low-level control if you want this, so you can adjust everything that you need. And the cool thing is that once you make the adjustments, it automatically visualizes it on the other end. And so you can do all these simulations that gives you very fast iterations for your design parameters.
I have a question. You showed a brush. Did you actually use it for painting? Because real paintbrushes have very particular materials. And did you explore the space of materials to see what interesting properties you could get?
So that is actually a good observation, and we realized that it's the same flowiness and the same texture for like actual brush for painting, but we never actually just ventured into the idea of actually using paint to do it. But I speculate that it's possible. Also, we did another brush that has thick bristles, kind of like a toothbrush. So that's also like another possibility. But yeah, brushes would be possible.
You mentioned braiding.
Yeah.
Did you actually use it as part of the braiding process or post?
That was post-process. So
You
you
ever
braid,
thought about-
you braid the straight hairs like this, and then you just braid it yourself, or put a ponytail on it.
What structures for the printing process? I mean, could you imagine actually as part of the printing process actually kind of braiding?
Oh, like interweaving it? Like, I haven't thought about it, but that's a cool idea. It could be possible, yeah.